Okay, today we're going to talk about absolute value of products. So we're going to talk about some equations with the absolute value. We're going to talk about some inequalities with the absolute values and see what they mean, okay? So before we begin, let's review a little bit. Do you guys all remember, what do we do with expressions? We simplify. And here are some expressions. What is absolute value of -3, class?
3.
Good. What's absolute value of 3? 3, good. So you all know that. But if we have an equation, what do we do with equations? We solve. So let's take a look at this equation. Absolute value of x equals to 3. When you look at this equation, we're then looking for value of x such that when you plug in x inside the absolute value, the whole thing turns out to be positive 3. And it turns out there are two ways for this to be true. Does anybody know what those two cases might be? Yeah, there.
X equals 3 or x equals -3.
X could be 3 or x could be -3. You see, I'm looking at inside the absolute value. X could be 3 or -3. So using this kind of logic, we could actually solve something that's a little bit more interesting. If you just have absolute of x equals to 3, that's pretty simple. But what if I have, so there are two answers. What if I have absolute value of 2x plus 1 equals to 5? In this one, it's not that easy to see, right, what that x could be. But the idea is saying, look at what's inside the absolute value. You see that expression 2x plus 1? We're really asking ourselves then, what can 2x plus 1 be? So that the whole thing, when you take the absolute value of it, equals to 5. There should be two cases again. What do you think? Oh, not just the x. I'm talking about this whole thing, 2x plus 1. What can 2x plus 1 be? Savannah? Yeah, it could be 5 or -5. So it turns out, you could actually really think about solving absolute value problems, right? If you have an equation with the absolute value, you could think about actually having two equations, right? One of the equation is same as it was before, without the absolute value. The other equation is then 2x plus 1 could be what? -5. It's opposite of that 5. You see what I mean? So you could think of it as solving two equations. Does that make sense? Because look, inside is this absolute value. It could be 5 or it could be -5. Because as long as you take the absolute value of it, it'll be 5. Do we know how to solve these two simple equations? Go ahead, everybody do it. I'll give you time. So a lot of you already have the answer. So who has the first? What does that first equation become? Owen?
The answer or the...
Oh yeah, the answer for the first equation. X equals to 2. Did you get that? Okay, good. What about the other one? Judy? X equals -3. You see, it just becomes a simple equation, really, but you just have two of them, right? And we could verify it could be -3 or 2. Look, if I were to plug in 2 here, what's 2 times 2? 4 plus 1? 5. The absolute value of 5 is 5. You see how it makes it true? Also, if I plug in -3, what happens? What's 2 times -3, guys? -6 plus 1? -5. Uh-oh, we got -5. Is that okay? Right, it's okay because now that's inside the absolute value. So what's the absolute value of -5? 5, you see? So there are two possible solutions for this. So it turns out whenever you have an equation with the absolute value, you just need to get the absolute value by itself, okay, and then separate into two equations. That makes it true. Do you see the idea? So with that idea, what about this? Absolute value of x over 5 equals to 2 equals to -4. So this then changes into two equations again, doesn't it? We have the absolute value by itself. So what can x over 5 minus 2 be? It could be either 4 or -4. You see how it turns into two equations? Right? And do you see why we need to use the word or here? Why do we need to use the word or? Remember we learned this last time. What does or mean? Yeah. Yeah, or means we take the solution of either one of these, right? We include solution of both. Does that make sense? Right? So there are two possible ways. That's why would it make sense to put and in the middle?
No.
No. Why not?
Because that means it has to be for both.
Yeah. Like for example, one on the top. Can a number be -3 and 2 at the same time? Is that possible? No. Number is just one number. Yeah. Go ahead. Everybody go ahead and finish this up. See what you get. So when I add 2 to both sides on the first equation and then multiply both sides by 5, who's got the answer for the first one? How about Christine? X equals to 30. Good. What about the other one? When I, again, add 2 and then divide by 4. Emily, H, what'd you get? Negative 10. Again, there are 2 possible solutions, right? So does it make sense to write X could be 30 or negative 10? Yeah, you wouldn't say X is 30 and negative 10, right? Because X can't be 30 and negative 10 at the same time. You know what I mean? That's why we use that word or for these. Does this make sense? This is pretty straightforward. Now, it gets a little bit more interesting when we replace the equal sign with an inequality. Okay, what would this mean then? Turns out the process is pretty similar. So write this down. Let me move it up for you. Okay, so let's do this one together. It turns out, like I said, the process is pretty similar as what we did before. I'm not going to go into too much into detail in terms of why we do it, but I'm just going to show you how to do it first, and later we're going to come back and kind of think about why do we do these things. So first of all, what you do is just, anybody have any guess? Just like what we did with the equation, guess what we're going to do first with this absolute value? Yeah. It's going to be separated into 2. Now, it's not an equation anymore. It's going to be an inequality. So you're right. We're going to now separate them into 2 inequalities, just like how when we had an equation, we separate into 2 equations. So first, when I write the first inequality, can somebody guess what my first inequality might be? It's kind of same as before. 2 people could guess. Anybody? Yeah. What do you think?
3k minus 2 is less than or equal to
Yeah, exactly same as what we had before. That's our step 1. Okay. So it does become you could write these into 2 inequalities. And the other inequality, anybody want to guess what that other inequality might look like? By the way, what do you think? Do you think 7 we have to change into negative 7? Do you think that's all? No, you would also have to reverse. You have to reverse this inequality symbol as well. So that's step 2 and 3. Step 2 is to reverse the inequality symbol. Step 3 is then write, instead of 7, you write opposite of 7. And step 4 is you need to write and in the middle. Okay, that's the part where you have to kind of memorize. You have to put and when you have the absolute value by itself and you have less than symbol. Okay, less than symbol. So you have to memorize that, okay? And we'll explain to you why we need and there, not or anything like that, okay? Yeah, Judy?
So if it's greater than or equal to, would it be or?
Yes, if you had greater than or equal to symbol, if you have the absolute value by itself, very good. If you had greater than, right, or equal to, or just greater than. It could be, it doesn't have to be, you don't have to have this equal to sign. It's, if you have greater than symbol or less than symbol. So if you have less than, it's and. If you have greater than, it's or. And there's a way to kind of remember. So look what I did here. Less than, and you know, have less than and. But somebody said, wait a minute, greater than still has than in there. So that doesn't really help. Well, we'll get there in a minute. But for now, remember less than for and for greater than, we'll explain. I'll show you another way of remember. So for less than, okay, even though they both have than in there, for less than, think about it as less than and, okay? So you need and. And do you know how to solve these inequalities?
Yes.
Yeah, when you have 2 of them, when we have combined inequalities, right, we know how to solve this. Didn't we do this last time? Go ahead, everybody try. I'll give you time. Solve for k and go ahead and graph. Don't you have to graph it to see where the solutions are? Okay. Yeah, question?
So when it's and, it changes.
Okay, so when it's and, you just if you have the less than symbol, okay, you need to write and here. Yeah, you still have to reverse these, both of these, the symbol and the number. But what I'm saying is, how do we know it's and? Well, just remember less than and and. Okay. All right. Go ahead. So Audrey, when you solve for k for the first inequality, what did you get? K is less than or equal to 3. That's what I got too. Good. Lindsay, what did you get for the second inequality when you solve for k? K is less than or equal to, isn't it greater? Yeah, did you reverse the inequality symbol when you rewrite it from the top? Okay, yeah, make sure you do that, guys, because if you forget to do that, look, we had less than symbol here. When you rewrite this, right, step 2 is to reverse the inequality symbol. Not only writing the opposite of what you had up here, the number, you have to reverse. Does that make sense? Yeah? Right. Is that what you forgot? Okay, so when you graph, here's my scratch work, right? And as you can see, they overlap between -5/3 and 3. So what should my solution? What should my solution be? 2 people? No? Malia, what's my? Correct. All real numbers between negative 5/3 and 3. Including the endpoint. Sorry, yes. Including the endpoints. Good. Okay? Does that make sense? So in other words, if I were to plug in, like, I don't know, 0 into this absolute value, isn't 0 between negative 5/3 and 3?
Yes.
Right? Would that be my solution? What about, would 1 be my solution? 2? 3? Yeah? What about 3.1? No. Okay. What about negative 2? No. Do you understand? Negative 1. What about negative 1? Yes, it's in between. Does that make sense? You could verify. You could actually plug in those numbers. Let's plug in 0. What's 3 times 0? 0. And then 0 minus 2 is the absolute value of? 2. What's the absolute value of 2? 2. So is 2 less than or equal to 7? Yeah, see how it works? Do you understand? Okay. All right, good. Then let's look at the next example. By the way, this you could write it as, the shortcut, right? K between negative 5/3 and 3. You guys remember that? So you could either write it this way, okay, up here, K less than or equal to 3, and K greater than or equal to negative 5/3. But you have to also understand, right? This is a shortcut of that. Same thing. Example 5. Now you have absolute value 3k minus 2 is now greater than or equal to 7. So, question? Okay, this time it's going to be OR. Yes, you're right. So you're going to get 2 inequalities. Can somebody give me the 2 inequalities that we get? Harrison, what's our first inequality? Hold on, let me move it up for a second. Yeah, Harrison, tell me what the 2 inequalities that we get from this absolute value. Yeah, so first inequality you get is really easy. It's the same exact thing we had before without the absolute value. Step 2 then, and 3, you have to do something. Okay, how about Lindsay? Lindsay, tell me what to write as our step 2. We have to rewrite this now as? Yes, you need OR. Very good. I told you that already. OR. And step 3. Yeah. What's the inequality that we get here? 7? Negative 7. You got to do 2 things, right? You have to. You have to change the inequality to the other way, right? It was greater than, then you need to change it to less than. And then instead of 7, you need to write it as negative 7. That's why there are 4 things you do. You see how you can remember greater, right? I spelled it greater on purpose. Greater goes with OR, okay? Does that make sense? So just think about it this way. You won't forget. Greater goes with OR, less than is and, okay? We'll explain why this is true later. Okay, we'll show you why this is true. But just remember it this way for now. I just want you to be able to do this correctly for now, okay? So think about greater, greater. Okay. So this is what you have to do. Do we know how to then find the solution for these combined inequalities? Yeah, go ahead. Okay, so who can then tell me what I get for the first inequality? How about Christian? What'd you get? K is greater than? Equal to 3. Okay, good. Andrew, what did you get for the second one?
K is less than or equal to negative 5/3.
Less than or equal to negative 5. That's what I got too. Now this is OR. You guys remember what OR means? No, so, you're right. You're right. But then when you graph them, here's my scratch word. By the way, how come I put a big X on this? Why is this wrong? This right?
No, that's wrong.
Why?
No, it goes the way.
What? Caroline, why is this wrong? You're right. Huh?
Oh, you switched it.
Yeah, the negatives are on the right side.
Yeah, guys, I see this a lot on the test. Listen. Caroline, look, here's 3. I put 3 right here. And here's negative 5/3. I put negative 5/3. Is this right? No, why not? Yeah, it's smaller than 3. It should be on the left side, right? Why do you think people do this, by the way, on the test? Because I see this on the test a lot. Yeah.
Maybe because like 5 on it, like all 5 is bigger than 3, and they neglect to see the negative.
Yeah. Also.
Because the 5/3 was the first one.
Yeah, negative 5 thirds is on the right side. As you're solving this, it just happens that bigger number was on the left, and then they just don't think about it. If you do it this way, you're not gonna get the right answer, right? Okay, so what should the answer be? Yeah.
All real numbers less than negative 5 over 3 and greater than 3, including negative 5 over 3.
Correct. And it should look something like this, right? So we need to include the, right? Or means we want solution of either one of these is fine. So we include both of the solutions, right? How many people got this? That's your answer. Does that make sense?
Yes.
So do you see why it's important to put down the right word in the middle? Imagine if you put, by mistake, you put and here. What would your solution be for this? No solution, you see? So you have to know, when you have the absolute value by itself, if it's greater, it's or. Okay, does that make sense? Absolute value by itself. All right, so what about question?
Would it be like the answer be like graph, or would it be k greater than or equal to?
Good question. So on your homework, it'll be clear to you in terms of, so if you just, they would either ask you to graph it or write in words. So we would say all real numbers less than 5 thirds or greater than 3, including the endpoint or something like that. Good. All right, so let's look at example 6. Let me move it up for you, hold on. Okay, so this is kind of the problem that people make a mistake a lot. So I got 4 plus 3 times the absolute value of 5x plus 1 less than 18. What should we do first? Could we write this as two inequalities right now?
No.
Not right now. So we have to get the absolute value by itself, don't we? So let's do 4 plus 3 first. Isn't that right? That's 7. Should we do that first? No, that's how you get it wrong. It is so nice. When you look at this, people can't, they look at 4 plus 3 and go, I know what that is. They just write 7. Then you get it wrong. Why would that be wrong? Why can't we just, because it's so inviting, isn't it? Just 4 plus 3 is right there. Why don't we do that? Yeah, why don't we do that?
Because the 3 is multiplied by.
Yes, there's a multiplication right here. Isn't that right? So you have to follow the order of operation. You can't just add it first. Does that make sense? So then how do we get the absolute value by itself? Kobe?
Subtract
Yeah,
4.
you need to subtract 4 from both sides first. Okay. So to get the absolute value by itself, don't add this first, okay, even though it looks really nice to do it. And then you have to, of course, divide both sides by 3, and you get this. Somebody said, could we distribute this 3 inside the absolute value? Don't do that, because absolute value is not like the same as parentheses. Does that make sense? So just get rid of it, okay? This is the easiest way, okay? So just get rid of everything, right, that's around the absolute value first. Then you have absolute value of 5x plus 1 is less than 14 over 3. And Shurok, do you see how we're going to get then 2 inequalities? And what word should go in the middle? And or? And. So would that be a conjunction or disjunction? Conjunction, very good. Okay, so somebody tell me what to write here. What are the 2 inequalities that we get? How about, who haven't I called today? I have not called. Anais, tell me what to write.
5x is greater than 14 over 3.
What about 5x plus 1? Isn't it 5x plus 1?
5x plus 1.
Yeah, okay, good. It's the same exact one without the absolute value.
And then it's
What word goes in the middle?
And
And, good, because it's less than. Okay, then.
it's 5x plus 1 is greater than negative 14 over 3.
Excellent, yes. You need to reverse. There are 4 things you can do again. You need to, reverse the inequality symbol, write the opposite of the number we had up there, and then write and, right? Do we know how to solve, right? This inequalities, right? Go ahead, everybody try it. I'll give you time. All right, Sophia, what did you get for the first inequality when you solve for x?
I got x is less than 11 over 15.
11 over 15? Okay, let's see. What are you going to do first? How do we get rid of this 1? You're going to subtract 1 from both sides. Now, I wrote negative 3 over 3. Isn't that the same as 1? Why did I do negative 3 over 3? Because you need common denominator. So, yes, you get negatives here then you multiply. So, you get 14 over 3 minus 3 over 3, which is 11 over 3. Then multiply both sides by the reciprocal of 5, which is 1 over 5. So, you're right. You get x is less than 11 over 5. So, is that okay? All right, what about the second one? What do we do next? How about Kyle? Were you able to do the second inequality? Solve second, yeah.
You subtract 1.
Right.
And you get 5x is greater than negative 17.
Good. And then you multiply both sides by 1/5, right? What did you get? X is
This is greater than negative 17.
over.
Greater than 17 or 15.
Correct. Okay. And now we have and in the middle, right? Remember this was a conjunction because it was less than. You guys remember? After we have the absolute value by itself, we had less than, right? So what does then the graph give you? Here's a scratch work. Hopefully you have the right scratch work like this. And then when you graph this, how about Lara? What'd you get? When you graph this, and means what? We want the the overlap. So what's the answer? All real numbers between? Good. And do we need to include the endpoints, guys? No. And of course you could write it this way. K is between like this, if you wanted to. They mean the same. It's pretty straightforward. Okay, so do you think you could do something like this for your homework tonight? Well, not tonight, but later. Homework later. Okay, you won't have homework today, but. All right, let's try the next one. All right, so example 7 again is a similar format. You got 5 minus 4, absolute value of 2 minus 3x is less than 21. Are we going to do 5 minus 4 first, class? No. Okay. Is this going to have and in the middle or in the middle? Well, don't you see a less than symbol here? So how many people say, well, I only see the less than symbol. Why is it or? Okay, that's good, very good. You cannot tell whether or not you have and or until you have the absolute value by itself. Right now, it looks like it's and because you have less than symbol, but when you subtract 5 and divide by negative 4, when you divide by negative, what happens to the inequality symbol? It reverses. Now, do you see how when I have the absolute value by itself, you get greater? Yeah, Sophia? Could you add 4 first? That would be wrong because this is 5 minus 4 times this absolute value. Does that make sense? If you add 4 first, it does not get rid of this, right? Negative 4. It's multiplication. So you have to subtract 5, then divide it by negative 4. If you do it the other way, it's wrong. Yeah?
So when you do like absolute value of 2 minus 3x is greater than negative 4, if you change it to positive 4, would you have to switch that inequality sign?
You want to change that to positive 4?
Like you have to do
Right, very good. So let's write down the 2 equations. What are the 2 equations that you will get here? How about I haven't called Nelly? What do you think? Good. Same as before without the absolute value. And then what? Less than 4. And what word do we need in the middle? Or. Isn't that right? Okay. Go ahead. Everybody finish it up. Okay. So did you all subtract it 2 and then divided by negative 3? And when you do, what happens to the inequality symbol, guys? It reverses. So did you all put down x is less than 2?
Yes.
Good. The other one, you subtract 2, then again, reverse because you're going to be dividing both sides by negative 3. Did you all get x is now greater than negative 2 over 3? Okay. Let's do a little scratch works. This is what you would get. Right? X is now less than 2. Open circle goes to the left. X is greater than negative 2/3. Open circle goes to the right. What do you think then my solution is now that you have or in the middle? Somebody I haven't. Elizabeth, what do you think? So you think it's the overlap? That's when you have and. Remember, and means we want a solution for both. Or means solution could be either x less than 2 or x is greater than 2/3. We want solution of both of them all together. Not quite. Chansu, what do you think? It'll be all real numbers, right, Elizabeth? Right? Because or means we want a solution of x less than 2, all of these, plus all the solution of x greater than negative 2/3. Right? Does that make sense? Now, how come I don't have open circle at negative 2/3? Because there's open circle here. How come I don't have open circle here? Savannah, what do you think? Why do I not have open circle? Why do we include negative 2/3? That's our solution. Right. Negative 2/3 is not a solution for x greater than negative 2/3, but it is solution for, yeah, the other one, x less than 2, right? All the numbers less than 2 includes number negative 2/3, does it not? What about 2? 2 is not a solution for x less than 2, but it is a solution for x greater than negative 2/3, isn't it? Right? 2 is included in there. That's why we include everything. Any question? Does this make sense? Yes?
Yes.
Pretty straightforward? Okay. Next time we will try to explain why, right? We need and or for these. But if you actually think about this, this absolute value of number has to be greater than negative 4. It kind of makes sense that, well, any absolute value is always going to be greater than negative 4, isn't that right? That's why you could plug in any numbers here. Does that make sense? And you can kind of think about it that way too. But anyway, okay, so that's,
Oh, yeah.
yeah, okay. So that's it then.